Okay, so I think it's fine now. I believe you can record now. Can you record now, Rachel?
Yes, I can.
Okay, good. So I give you an example of if mobile money failed to work for a week, that would be disastrous. I have worked in some of the systems that some of these telecommunications companies use. By the way, I'm of a telecommunications engineering background, but anyway, all these things are interrelated. We definitely have had to have knowledge of safety critical systems within our field. I worked with a number of people who are from IT background, definitely computer engineering. These are all really related courses. Of course, I know in some places they differ, but now now the world is really becoming small. The biggest thing right now is cloud. It is cloud. So in the end anyway, whether you're doing computer engineering, electrical, telecom, IT, depending on what you want to do anyway, it's very good to have knowledge of cloud, AI, artificial intelligence. Yes, in that direction. So all these things are interrelated anyway, in one way or another. Yes, I was talking about the system, the failures. The failures can even result in huge costs. I was talking about mobile money. If an entire week a system is down, actually they can't accept that can't happen because it will be so terrible. But even if it happened just for one day, even if it happened for 1 hour, that's a very huge loss. I've worked in some of this equipment of the telecom companies. It's really expensive, by the way. Some of it is really expensive, in hundreds of millions. Some of the equipment, however, having the system down and having an error might even cost you more than that equipment, because the transaction that happen on a daily in mobile money, it's alarming to the extent that I think we all know, even the government even had to come in, separate MTN into the telecommunications and mobile money being managed by Bank of Uganda. Same with Airtel money being managed by Bank of Uganda, because they couldn't miss on this huge cake. And that's just an example, really, of what. Okay. Information loss is another. Dependability is very important, because if you have information loss, some information is not even worth the cost of equipment. I'm sure maybe at some point you've all lost a laptop or a flash disk. I've had a laptop stolen from me before, but the information which is on the laptop may be more valuable than the laptop itself. If you have historical data of a nation, that may be much more valuable than the computers on which it is sitting. Because once it is lost, you're not going to have this. You're not going to be able to get back this information. But anyway, where I've reached, I told you with cloud, for example, storage is something which is really backed up in so many ways, virtually backed up. The advancements have really gone far when it comes to technology. They have really gone far. Okay. So these critical systems, they use different techniques to develop them. These techniques have been used for a long time, so they use them to develop in such a way. Once it's made, the system is reliable. Okay, it's dependable. I mean, dependable, and that means it's reliable, available, it is secure, it is safe. Okay, those four. The system is dependable. That means it is reliable, available, safe, and it's secure. Okay. So these methods have been used for a long time to ensure that the system that they come up with are safe. Okay. And we have the systems. Biosystems depend. Some systems are automatic, some systems are managed. Some systems are automatic, some systems are managed by users, as the examples I gave you. Some systems are automatic, some are managed by users. But remember also, users can also make mistakes. But that's one thing which you have to know here. Some of them are managed by users, some of them are self-managed, automatic. Okay. Okay. Before I go here. Okay, there are three system components where critical system failures may occur. Failures can occur in the software, failures can occur in the hardware, failures can also occur because of the human operator. Okay, human operator can make a mistake, the mistake can cause a hardware or software issue. Okay, human operator may fill in a wrong value may fill in the right value at the wrong time and then cause a problem. Okay, so failures can occur in those different ways. That's all they're trying to explain there. Okay. Systems have to be made in such a way that you cater, because you have to cater for this fact that you have to cater for the fact that these failures can be interrelated. If you make a system whereby you're making the hardware without being aware, without putting so much thought that a human being is going to use it, that can be a problem. And a good example is, imagine a paper cutting equipment. If you're making a paper cutting equipment and maybe you put one handle, you're being unaware that the other handle of the human being can be in the way and get damaged. However, as you're making a system, you're thinking, okay, the hardware should have two handles so that probably both hands can be operating the system. In that case, there's going to be less risk. Okay, that's you have to put into thought. These people who are manufacturing these systems have to put into thought that they are going to be used by people. Okay, remaining time is 1 minute, but remember, you just log back onto the same link. Okay, and then maybe we can finish within that next session for today. Yes, but that's so that you have to put into account that, because if somebody can cause a system to fail. We have had cases where pilots maybe their minds are tired and this causes a crash. So there, it's not the fault of the aircraft, it's not the fault of the hardware of the aircraft or its software, it's the fault of the human, but it has become related to the plane failing, to the plane crashing. Okay. So that's what they're trying to explain there.